In section 6, we talked about applications of exponential functions. So what I've done here is I have taken all of the formulas that we discussed, exponential growth and decay, and what each of the variables represent. I did the same thing for the compound interest and continuously compounded interest formulas. And then I also included our commonly used values for n for our compound interest formula. In our first example, we have the number of full-day students attending DACC increases by 2% each school year. If the current number of full-day students is 320, how many students would you expect there to be in 3 years? How long would it take for the number of full-day students to double? So two-part question. So the first thing I'm going to do is write the equation. And this does represent growth because it says in our problem that it is increasing. So we're going to have y equals our initial amount, 320, then 1 plus 2% as a decimal, 0.02x. So for our first question, how many students would you expect there to be in 3 years? So we're going to plug in 3 for x. So we'll have y equals 320 and then 1.02 to the third. And again, just plug that directly into your calculator. And we're going to get y equals 339.59, which again, because this is a number of people, we can't have a decimal, so we're going to round to a whole number, so 340 students. The second question asks us, how long would it take for the number of full-day students to double? So we're doubling our initial amount of 320, and double of 320 is 640. So now we're going to have 640 equals our initial amount, 320, and then our 1.02 to the x. My first step, divide both sides by 320. So we get 2 equals 1.02 to the x. Convert it to logarithmic form. So log base 1.02 of 2 equals x. And then using change of base, we do log 2 divided by log 1.02. And we're going to get x equals 35 years. It is 35.00. So even if I wanted to round 2 decimal places, it's still a whole number. So it would take 35 years. In our second example, we have that suppose your parents set up a bank account for you when you were born. They deposited $2,500 into an account earning 1.5% interest compounded monthly. How much money will be in the account when you graduate high school? 18 years. How long will it take the account to reach $20,000? So we have our compound interest formula. So we're going to have A equals our initial amount, 2,500, then 1 plus R, 0.015, over N, which is 12, and then our exponent, 12t. So my first question asks, how much money will be in the account when you graduate high school? So that'd be 18 years. So we'll have A equals 2,500, and then 1 plus 0.015 over 12 is 1.00125, and then my exponent becomes 12 times 18. So we're going to do this in the calculator. And we're going to get an amount of $3,274.36. So our second question is, how long will it take the account to reach $20,000? Obviously, it's going to take longer than 18 years because we know after 18 years is only at 3,200. So it's going to be a very large number. So we'll have 20,000 equals 2,500, and then our 1.00125, and then our exponent 12t. So my first step is to divide both sides by 2,500. And then we'll have 8 equals 1.00125 to the 12t. Converting it to logarithmic form, we have log base 1.00125 of 8 equals 12t. Using our change of base formula, we do log 8 divided by log 1.00125, and we get 1,664.593 equals 12t. Then divide by 12, and we get that t is 138.72 years. So remember, when you're solving for time for compound interest or continuously compounded interest, time is always in years at the end.